Today we're going to be having a look at how to find the area of a trapezium, as well as going into some applications of using this formula. So first off, we're going to have a look at what a trapezium actually is. So a trapezium is basically defined as a shape where two opposite sides are parallel, meaning that they will never touch, they go in the exact same direction. So whether it's this line here and this one, these two vertical lines, and sometimes they'll be on an angle like that. Usually we can tell if they're parallel by little arrows that are pointing in the same direction. So how do we actually apply the area? First of all, what is the area? So the formula that I'll get you to write down in your books is A equals A plus B times H over 2, right? Make sure that A plus B is in brackets. But take a moment to write that in your books. And let's have a look now at what A and B and H are. So the H is the height. We've used H before with a few different formulas. So that shouldn't be too hard to sort of understand. So H is the height. So between the distance between the two parallel lines. A is simply the distance across the first parallel line. And B, again, across the second of the parallel lines. So what we're going to do when we actually find the area of a trapezium, we're going to substitute those values into our formula. So here's our first example using that same shape. So what I'm going to do is I'm going to write out my formula. I need to identify what A, B, and H are. So H, that was a pretty simple one. That was going to be the height of it, which was 3 meters, which I'm going to substitute there. So remember, substitution was just replacing a letter with a number. A is going to be my top line, so 6 meters. B is going to be 10 meters. So when I substitute all those values in, I get a formula that looks something like that. So I've got 6, so that's A, B, and H. So 6 plus 10 in brackets, still in my parentheses. And I multiply it by 3 divided by 2. So that's just substituting the formula. The next step that I'll get you to write in your books, what I've done here, you'll notice that if you remember back to BODMAS or PEMDAS, whichever you'd like to use, I've made sure that I do whatever's inside the brackets first. All right, so I did my 6 plus 10 first to give me 16. That times 3 divided by 2, we haven't used those yet, so they just appeared on my next line of working out. So I've just done 6 plus 10 to get 16 times 3. 16 threes give me 48. That divided by 2, still haven't used it. So it's asking me now, how many 2's go into 48? Easy as. So this trapezium is going to be 24 meters squared. Now, those 1, 2, 3, 4, 5 steps is probably what I'd expect to see in your books, making sure you're working down the page. Another example, which I should have probably put in step by step, but this one's a little bit different in that the A and the B are on the vertical lines. If you turned your this shape sideways on its side, we'd have A and B on the top and bottom like we did on the previous example. But I know that A and B, given that these two lines here are the parallel ones, the ones that are going in the same direction, they're my A and B units, whereas the height this time is going to be my 2. So I substituted 1.8 and 3, so A plus B times the height, which was 2, which gave me 4.8 times 2, 9.6. Then we divide it by 2, I end up with 4.8 meters squared. Now, hopefully that made a little bit of sense, but what I want to show you now is how we can actually, how we can actually apply this to a real life situation. So a lot of people who are in the trades, you need to be able to quote how much something will cost. If you're, for example, laying carpet, you'll need to know how much the carpet will cost per square meter, so that when you write someone up a quote, you'll know how to quote it properly, so that you're not ripping them off and you're not underselling yourself. So I've basically used the same shape that we just used in the previous question. However, the application question is this: a painter wants to paint a wall. He knows that the paint he uses costs $6.50 per square meter of wall that he has to cover. that he has to paint on a wall. How much will it cost him to paint the wall? So we remember that the wall was 4.8 square meters. So in order to find out the cost of something, we're going to look at the cost equals the area, which I already know is 4.8 meters, multiplied by the cost per meter squared. So 1 meter squared was $6.50. What will 4.8 meters squared cost? So I substitute my values. So my area was 4.8 meters. The cost per square meter was $6.50. I just simply pop that into my calculator. 4.8 times 650. It spits out a cost $31.20 to paint this particular wall. So that's similar to a couple of the application questions that you might come across. Hopefully this tutorial has helped you out.